let's now develop the solution for the getPaymentDue accessor method. So that's the method we would like to develop. However, given what we have seen so far in the previous videos, we know how to manipulate the multi-valued reference type attributes facilities, and also how it works together with NOF. And also we talk about how you can use the add facility method to actually gradually add the objects from left to right into the array. So as long as you understand it, programming this method will be quite straightforward. It's a very simple algorithm you will have to code, but it's just important to visualize exactly why it will work. I'll do that briefly. All right, before I do this, again, I'm going to write a test case first to really understand exactly what should be expected to be returned from this method here. All right, let me go back to test member over here, maximize it. And then let me now develop a new test method. Okay, let me just go to the center over here. Okay, and so let's now define a new test. Let's say public void test number 2. Okay, and for this particular test, we're going to test for getPaymentDue. Yeah, I don't need to say that. Actually, you're gonna see that in the method call. All right. So what we will do is we're just going to reuse some code. Okay, you know what? We can simply reuse all of it. I'm going to delete some irrelevant code in just a moment. Copy this from 1A and paste it. And you can definitely try to set up the member objects by calling either the overloaded method, which will take, rather than facility objects, you will take the string, double, and int. The overloaded version. Either you can do that, or you can also use anonymous object to set up the member object. I'll leave that to you. But for now, I'm just keep it simple over here. So I'm going to, I don't need to check this anymore. So since we have done that previously already. So let me get rid of all the previous assertion. Okay, you don't really need to duplicate assertions among test cases unless you really want to. All right, so now we got F1, F2, F3, and we understand very well up to here about how things work, right? That's what we did to visualize in the previous tutorial. All right, so now what I want to do is I want to call that particular getPaymentDue method, and then we want to work out exactly what should be returned. Well, this one is quite easy, straightforward conceptually. So I would say assert equals over here. So we can say, basically, we want to get the unit price of each of the facilities multiplied by its units, right? Unit price multiplied by units and add them up together, get a summation. That's what we'll do. So the first one is going to be 2.5 times 1. The second one will be 2.0 times 2. The third one will be 1.5 times 3. And depending on how many facility objects you might have in the facilities array, right? But in this case, only 3. So I will just make, rather than giving the ultimate result, why don't I simply write down some expression. 2.1 multiplied by 1 plus 2.0 multiplied by 2 and plus 1.5 multiplied by 3. And then, so this will be expected result over here. And then what will be the actual result? It's going to be returned by here, the context object dot getPaymentDue over here. And then since we are comparing we are comparing floating point values, so we can we have to give some tolerance. Let's say 0.01, like that. All right, so that's the test case. So I would really encourage you, for those of you who, once you go beyond this course, since you already know how to write some simple JUnit test cases, so it would be recommended, sometimes even before you try to program the method, try to write some test cases just to specify how you expect the method to return. That'll be also very useful for your development as a guidance. Right? Of course, if I simply run the JUnit test, it would fail. No problem, right? Because you're simply expecting 11.0, for example, but you're simply returning -1. We haven't done anything just yet. That's why. All right, let me go back to the member class and let me program this. All right. And I already gave you some hints over here. We want to go over the facilities array, basically. And then we want to simply add up the price times units for each booked facility, right? And there is something I would like to remind you about before I actually start coding this. So let's now recall this diagram here, right, from the previous video. you can see for this particular setup, we actually got 3 facilities objects, 1, 2, and 3, and F1, F2, F3, right? That's what we got. So now here's a question here. If we want to run a loop, so what should be the number of iterations? Should it be 3 iterations, or should it be 6 iterations? Because the maximum index for the array is actually 5. I can think about this is a very possible scenario where the capacity of the array is actually 6, but you have only filled in 3 slots of the array. So now the question is, if I want to calculate a unit price, should I actually use should I actually run 6 iterations or 3 iterations? That's the question. Okay, it's quite obvious we should really get 3 iterations, right? But now, what should be the upper bound for the loop counter? Do you know what should be the loop counter upper bound? NOF. That's really important over here to see, because you can see at the moment for this particular setup, we got 3 objects already filled in into the array. So that means we should only go up to and including index 2. That's what we should do. And the NOF really tells you that's really the value that that should not really go up to, right? So now, so you would be anything that's strictly less than NOF, which will go for 0, 1, and 2, but not including 3. So that's really the rationale of figuring out the loop we're gonna run. All right, let's do it, and then I'll show you what's going to happen if you didn't really do this one. If you simply use the length of the array as the upper bound. I'll show that to you, but let me just give you the correct version. All right, it's really important for you to see that, right? This visualization has been done previously thoroughly, so I assume you already understand it. Right? Let me go back to the Eclipse over here. So what we will do is we're going to say for integer I is assigned to 0, initialized to be 0, I strictly less than this dot NOF, right? So NOF will tell us exactly how many there are, but we only want to go strictly below. And then I plus plus. Sorry. Okay, and then for each one of them, we're just going to get the corresponding objects. For example, here we might go to index 0, which is going to give us the particular facility objects, and then we can calculate the price and also units, right? That's what we can do. However, for that one, let me just do one more thing in the facility, so just to make sure this can help of the computation. Let me just go to facility over here. Okay. So let's say we define some accessor method. It will be up to you. You can say you can get accessor method for get price and get units. But now let me make it even easier for you. I can say public, let's say double, get payment due. Okay, so you can see we also got one payment due for individual facility, as opposed to get payment due for a particular member, right? Just notice the difference. So if I go back to facility over here, get payment due, you will simply just return this dot price multiply this dot units, right? Easy to program. And then let me go back to member over here. So what I should do is I can really have maybe the summation for the payments. So I can say double, I can say result, that's okay. Initially 0.0, and eventually I want to return the result over here. Okay, and then I can say now, how do I get a payments for individual facility? I can say result plus equal this dot facilities array at position at index 0 dot get payment due, right? I'll explain this when I trace the code together with you. Alternatively, you can also write this. Okay, so if you are not so comfortable with this complicated expression over here, you can write it this way. Alternatively, okay, you can simply declare some local variable. You can say facility, let's say f is assigned to this dot facilities at position 0. Okay, that's one thing you can do, right? And then you can say result plus equal f dot get payment due. So this will be this can be something you can do, right? Basically, you're simply saying this particular part over here, I'm simply giving a name called f over here. So you can think about this part here is simply some expression I can write on the fly, and then this one is going to give me the facility objects that's pointed by this particular index over here. Oh, you know what? It should not be 0. Beg your pardon. It should be I over here. You might have noticed that because I will be going from 0, 1, 2, 3, 4 all the way to NOF minus 1, right? So this should be I rather than 0. All right. So that will be the algorithm. Is pretty easy, but you should just know why it will work, which I will explain. Let me now run the test over here. Let me go back to test member over here and run it. All right, so it's a green bar. So now everything works. Okay. Let me just show you one more thing over here, and then I will trace the code together with you quickly on the iPad. Let me go back to member over here. What if, alternatively, what if I say rather than this .NOF, what about I just go with a standard loop upper bound? I will simply say this facilities.length. What if I do that? Okay, if I do that, let's say if I do it, and then I got something called, you can see null pointer exception. Null pointer exception over here. All right, so keep that in mind, and then I'm going to explain this actually when I visualize the code together with you. Okay, so just notice that you must, if you simply say this facilities.length, then you might run into null pointer exception, meaning that you are actually going to call getPaymentDue on this facilities I object here, which might be storing simply null because you already go beyond the points for NOF. Right? That's what I want to say briefly, but I'm going to trace that together with you. Okay, so let me just make a note for you over here. Okay, let's just change back. I less than this .NOF. Okay, and then I want to make a notes explicitly over here for you. Okay, notes having the loop state condition. If I simply do this, will result may or may not actually may result in a null pointer exception. The only scenario where a null pointer exception cannot be resulted is when this .NOF is equal to this facilities.length. So what I'm trying to say over here is, so in the case where, let's say here we got 6 slots in the array. If the NOF is simply just equal to 6, in that case, NOF is simply the same value as the length of the array. In that case, that means every slot in the array is simply filled in with some non-null address. In that case, it would be okay to actually write the loop counter like that. However, you cannot rely on that particular case in general. So that's why you just cannot say this. So I'm just trying to give you some special property about NOF, between NOF and also the length of the array. So this should be what you should write over here. But don't memorize it. You really want to know why it should be written this way. Okay? All right, so let's now trace the code together.